NAS operates distinctly from block-level storage area networks, SAN. NAS devices are optimized for file service through their hardware, software, or configuration, often structured as a purpose-built specialized computer appliance. These networked appliances hold one or more storage drives, frequently organized into logical redundant storage containers or RAID. Network-attached storage, NAS, is a file-level computer data storage server linked to a computer network, granting data access to a diverse group of clients. The term NAS can refer to both the technology and systems implicated, or a specialized computer appliance geared for such function, a NAS appliance or NAS box. Network-attached storage typically allows file access utilizing network file sharing protocols like NFS, SMB, or AFP. NAS devices rose in popularity during the mid-1990s, emerging as a convenient means to share files among multiple computers and relieve other servers of file-serving tasks. NAS systems commonly accompany purpose-built hard disk drives, akin to non-NAS drives, but designed with different firmware, vibration tolerance, or power dissipation to suit RAID array use, often employed in NAS setups. For instance, certain NAS drive versions endorse a command extension to disable extended error recovery, allowing for efficient data management within RAID configurations. In non-RAID environments, disk drives may exert extensive retries to read problematic storage blocks, potentially causing delays. Contrastingly, in a properly configured RAID array, redundant data across drives can swiftly recover a bad block, evading drive failure flags and ensuring system continuity. Manufacturers produce NAS devices using three distinct types: computer-based NAS, which involves utilizing a computer with processors like Intel or AMD, installing FTP, SMB, or AFP software servers. This type consumes the most power but offers robust functionality. Companies like Synology, QNAP Systems, and ASUS are known for making these devices. The second type, embedded system-based NAS, utilizes ARM or MIPS-based processors and a real-time operating system to run a NAS server. The power consumption is moderate, catering to most end-user requirements. Chipset manufacturers like Marvell, Oxford, and Storlink cater to this kind of NAS, with FTP throughput rates varying from 20 ms to 120 ms. The third type, ASIC-based NAS, employs a single ASIC chip for implementation, with hardware acceleration circuits handling performance operations. This NAS type boasts low power consumption but offers limited functions, supporting only SMB and FTP protocols. Layerwalker is the exclusive chipset manufacturer for this category, with a maximum FTP throughput of 40 Mbps. NAS devices are versatile, serving purposes beyond centralized storage for client computers in data-rich environments. They facilitate cost-effective systems like load balancing and fault-tolerant email and web servers by providing storage services. The consumer market, particularly for multimedia data, shows promise as NAS appliances become more accessible. These devices, often compact in size compared to rack-mounted units, have witnessed a significant price drop in recent years, appealing to home consumers seeking network-based storage solutions. Many consumer devices utilize ARM, x86, or MIPS processors running embedded Linux. Purpose-built backup appliances, PBBAs, serve as specialized NAS units designed for storing backup data efficiently. These appliances typically incorporate features like data deduplication, compression, RAID 6, and automated maintenance. Open-source NAS-oriented distributions of Linux and FreeBSD offer user-friendly setups on standard PC hardware, featuring services like Samba, NFS, and FTP daemons. Network-attached secure disks, NASD, represent a research project from 1997-2001 by Carnegie Mellon University, aimed at providing scalable storage bandwidth cost-effectively. NASD optimizes file server performance by enabling direct data transfers from storage devices to clients, minimizing file manager overhead. Among the various network protocols utilized to serve NAS devices are AFS, AFP, SMB, FTP, HTTP, NFS, rsync, SFTP, and UPnP. Additionally, clustered NAS systems employ distributed file systems across multiple servers simultaneously, enabling data and metadata distribution among cluster nodes. This setup provides unified access to files across all cluster nodes, regardless of the data's physical location.